Okay, let me pause this real fast. Because we have a test on, and I don't think I actually showed you the calendar yesterday, because I needed to see how far we got in notes. Long story short, I did not want another test for you guys on a Monday. I don't think that's a good thing. So if we finish 2-6 today, we will be good to have our test on Friday. Because our chapter only has 7 sections. So we're going to finish 2-6 today. 2-7 is tomorrow, because we're going to make that a short one. And then we're going to go ahead and have a review on Thursday, test on Friday. For a few different reasons, that's going to be helpful beyond the fact that Monday we have less time, number 1, and number 2, it's a Monday. We couldn't extend it till Tuesday. That just would mess up our calendar for the semester kind of royally. You guys have PSAT Wednesday. You have retreat Monday and Tuesday. It gets rough. So we just need to fit this test in this week. So let's go ahead and get to section 2.6. Here we are. Another test on Monday I just did not think would be a good thing for our class. So we're going to work hard. We're going to get done what we need to. We're going to be ready for that test on. Sorry, our workday will be on Thursday. Reviewing and talking about the test itself. Here we go. Goal. Figuring out what's going on at vertical asymptotes. Well, that's new. Yesterday we talked about discontinuities. We're in rational functions. We're talking about rational functions, aka, oh my goodness, hi, it just all disappeared. That's fine. We're talking about rational functions, and as everything comes back, that's what happens when your computer decides to be mad at the world. Sorry guys, I'm going to come right back with you as soon as it starts opening again. Okay. We have an F over a G. We have a numerator, we have a denominator. Question, where do problems occur in fractions? Domain problems, where do they occur? The denominator. What is the denominator of a fraction not allowed to equal? 0. So if we're trying to find the domain, of a function, when there's a fraction, we set the denominator not equal to 0 and we solve. However, even though there are domain problems from denominators, there can be, or there are, 2 different problems that occur, or 2 different types of what we would call discontinuities that occur. One of them is called removable, and one of them is called non-removable. Removable ones are holes. Holes are the ones that cancel out or reduce. They're still needed, or the domain is still needing to be restricted, because originally t couldn't equal -1. But after we reduce, we can make the whole thing look a lot easier. We can make it a lot easier to graph, etc. By doing that simplification, by reducing those factors out, everything is a lot easier now, but we just need to make sure that domain still is correct according to the original. But holes is one momentary lapse in the graph. One infinitesimally small hole. And that always happens whenever we can remove the discontinuity by factoring and simplifying. Vertical asymptotes can't be removed. That's why they're called non-removable. Then we started talking at the very end of yesterday how to figure out what's going on in your vertical asymptotes. Do you guys remember how I had, 4 different pictures up here on the board? And every single one had a vertical asymptote, right? But was every single graph the same? No. One of them, as you came in towards A from below and above, from the right and from the left, they both were not. One of them, they both went down. The other 2, they came in and went different directions, whichever way they went. In order to figure out what the behavior is near a vertical asymptote, we need to approach, and what's that symbol in math again for approaching? Little arrow. We need to figure out what F is approaching. And it's either going to be going up as it skims the vertical asymptote, or it's going to be coming down. So the first way to figure this out is with a table and or graph. You guys were supposed to get this into your graphing calculator, your Y1. And after you plug in the function -3 over x plus 1, in order to think about behavior, you're going to have to change your table setup to be ask, not auto. So remember, second window, you're going to need to go to ask. In order to check the behavior with a graphing calculator, you have to change your table to be ask. Now as you go to your table, we have to ask ourselves a few questions. First of all, what is the domain problem for this function? X cannot equal -1. Huh? Good. X plus 1 cannot equal 0, so x cannot equal negative 1. Why must I say that's a vertical asymptote and not a hole? It approaches but never reaches. Most people are going to be a little confused by that. The easier way is, can I cancel x plus 1? Can I reduce it with a similar, or I should say, with the same factor on top? No. There's no x plus 1 up there. Even if I try to factor, it's not going to work. So that's stuck. It's non-removable, and every non-removable one is a vertical asymptote. So I know there's a vertical asymptote at negative 1. And here's the dilemma. I need to think about then, on my graph, if I have a vertical asymptote at negative 1, I need to come from below negative 1 and from above negative 1. From the left of negative 1 and from the right of negative 1. And ask myself, what is f doing? Now, there is snazzy notation for how to write this. Do I actually have that notation? No. So instead, we're just going to use words because this notation is good for calculus. I don't go quite as in depth. We'll see it in chapter 12 this year. I'm not going to go super crazy. We're just going to say from the left and from the right. We're just going to use words instead of the notation. Notation gets a little tricky on this one. So from the left of the VA, from the left of negative 1, and from the right of the VA, from the right of negative 1, what is my, or what are my y's approaching? Now, can you guys see what I plugged in my table over there in the first one? Can you see what I plugged in my table for the first one? What kinds of numbers? Does the first table show from the left or from the right? Let me go ahead and split this up real fast. Just to make it a little bit easier. Looking at the number line, some of you already think you have an answer. I'm not saying you're right or wrong. But I have two different tables. Is this right or should I switch it?
There you go.
That's good? How do you know?
Because it's negative 5 is before negative 1 on the right.
If you were to think of negative 2, that would be over here, right? So this one is going to be from the left, from negative 2, which are numbers on the left. Negative 2, you guys see what I do, right? Negative 1.1, negative 1.01, negative 1.001. I'm getting closer and closer and closer. Closer and closer and closer to negative 1. Now, this one, negative 0.5, what side is that on? Yeah, isn't this negative 0.5? I guess I could have plugged in 0, but I just went straight to something close. Negative 0.5. Negative 0.9 would be like right there. Negative 0.99 right there. Negative 0.99 right there. But here's the question. Didn't you guys just tell me that negative 1 is a discontinuity? Didn't you guys just tell me if you plug in negative 1, this should be an error? What do you see in these tables down here, guys? This one says negative 1 is 30,000. This one says negative 1 is, do you guys know scientific notation? How many zeros are after the negative 3 in there? So that'd be negative 300,000. Whoa, wait, what? How can at negative 1 it be at 30,000 and at negative 1 it be at negative 300,000? Do you think I actually have a negative 1 in my calculator? Right? So far, so good? Still so far, so good, right? If I followed the same pattern, guys, how many zeros do you think I would have put next?
2.
How'd I get 30,000? By plugging in negative 1? Nope. I plugged in negative 0.0001. But what does the calculator do because it can't fit that many decimals in? It rounds it. So is this truly negative 1? The answer is no. Question. If I wanted to answer the question, as I come from the left, If at negative 2, it would be at 3. Negative 1.1, it's going to be at 30. Negative 1.0001 is going to be at 300. And negative 1.00000001 is going to be at 30,000. What are my f of x's going towards? Positive infinity. There are numbers, but the numbers indicate I'm going up and up and up and up and up and up and up. To go from 3 to 30 to 300 to 3,000? Yeah, I'm going up. So my f of x is approaching positive infinity as I come from the left. And kiddos, can you see on this one as you come from the right? Negative 6, negative 30, negative 300, negative 3,000? Negative, 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 negative. And then do you guys see how I have this one selected? Is that really negative 1? It's negative 0.99999. Yeah. I'm going to negative infinity. Or I should say my function is going to negative infinity. Does that make sense? So if we were to go in our graphing calculator, and you guys I think have this in there, hopefully you'll at least see what I'm doing as far as my table setup being asked, and then I can put in values from the left of the vertical asymptote, like this, from the right of the vertical asymptote, getting closer and closer and closer and closer, until you can see that it's going down, until you can see it's going up. If I look at the graph, it should match about what I have. What do you guys think?
Yeah.
Pretty good. Yeah. Now the one thing we haven't talked about is horizontal asymptotes, but before we get there, because we don't know exactly where to put this horizontal asymptote, because the one I did yesterday, didn't it have a funny horizontal asymptote, like way up here somewhere?
Yep.
This one, if you guys look at the graph, where does this one seem to have a horizontal asymptote? At 0. So it's kind of important to figure out horizontal asymptotes too, to know how to finish graphing these rational ones. We need to talk about, can we do this without a calculator? Can we do the whole behavior thing without a calculator? And the answer is yes, but how? How to use just math, no calculator, no graph, no table to figure out behavior near, aka from the left and from the right, x equals negative 1, which is your vertical asymptote. We still think of from the left. And we still think of from the right. And there is notation for that, but once again, remember, we're not talking about that right now. Do you guys remember? You just saw the tables just a second ago. What's a number if you're thinking about negative 1? What's a number that's barely, barely, barely to the left of negative 1? Negative 1.1 or negative 1.00000000001? Yeah, that's barely to the left, right? What's something that's barely to the right? Negative 0.999? Yeah, that. Okay. So here's what we're going to do. From the right, from the left. Almost always, sometimes it gets a little more complicated, but almost always, you can think about, what if I was just to plug this guy who's super close to the vertical asymptote? What if I was just to plug him in? And ask myself the question, what sign would the value have? Because ultimately, I'm just trying to figure out, is it going to positive infinity, so is it at positive numbers going higher towards more positive numbers, or is it in the negatives going lower to more negative? And almost always, by the time it's this close, you can usually tell by the sign if you just plug in 1. So coming from below, if we plug in negative 1.1, and coming from above, if we plug in negative 0.99, we're just trying to ask ourselves, towards a vertical asymptote, it's either going positive infinity or negative infinity. You just have to check the sign. So kiddos, on this one, don't even worry about what it actually equals. Ready? A negative 3 is always going to be negative. True? What's negative 1.1 plus 1? Negative 1.01 plus 1? Negative 1.00000000000000000, etc. 1 plus 1. What's the sign always going to be on the bottom?
Negative.
Coming from the left. What's a negative over a negative? Can you guys check with what we saw in our calculator? Is this the right answer? Yes. And I didn't have to use a calculator or a table or plugging in stuff in my calculator. All I had to do was plug in one that was super close, one value that was super close, and just check the sign. I didn't even care about the decimal or what it actually equaled. I just checked the sign. As Colby asked this question, you guys do the same thing over here on the right. Let's see if I agree. Go.
This is vertical or horizontal?
Vertical. I said we need to do horizontal, but let's see really quickly how to do the vertical without a calculator. Thanks for checking. So the numerator, what's negative 3 sine always going to be? And what? Negative 3 sine is always going to be a negative. But the bottom, negative 0.9, negative 0.99, negative 0.999 plus 1. All of those are going to have what sign? Because the 1 wins. And what's a negative over a positive? Put on an infinity. Check with what we found on this page before, and are we right? It's a trick. It usually works. The one time it won't work so well is if we have a quadratic in the denominator. We're trying to plug in something that gets squared and compare to like other terms. It's a lot easier if you have it all factored to plug in. If you weren't to have a calculator, or I was to ask you to show me with the math why it's true, you could technically just take one value really close from the left, one value really close from the right, and at the end of the day, check the sign. Okay? Now it's horizontal time. Now it's horizontal time. A horizontal asymptote, when does it happen? When does it occur? When f of x approaches a constant, not an infinity, a constant. And this constant, y equals L, would be a horizontal line. When the y values approach a constant, aka a y equals constant, aka a horizontal line, f of x approaches a constant or horizontal line as, now here's where we have to review some notation. I'm going to technically change this just because of the calculus thing that we saw. I'm going to say and or. It could be an and or it could be an or. Do you guys remember what the notation x approaching negative infinity means, like in words? We've used that one. It was back with the leading coefficient test, the end behavior test for polynomials in section 2.2. Careful. X approaching negative infinity, think of a number line. Pick an x and you're approaching negative infinity.
To the left.
You're going left, right? Don't worry, I always do stuff from your perspective, at least I try to. Number line, x value. What if you're going to positive infinity? Going to the right, right? So this would be to the left. And this would be to the right. Just reminding ourselves of what the notation means. And when will horizontal asymptotes occur? The easiest way at our level without knowing calculus was going to do degree tests. Just going to do degree tests, and you should recognize that somewhat from last year. So you have a rational function, you have a top, you have a bottom, you have a numerator, you have a denominator. You're trying to see if he has a horizontal asymptote. Vertical, look at G, it can't be 0. As long as it doesn't factor with the numerator, that's a vertical asymptote. But for horizontal asymptotes, we have to check, test the top with the bottom, and ask ourselves whose degree wins. if the top wins. That's messy. Probably just one. If the top wins, we have no horizontal asymptote since f of x is approaching positive or negative infinity. If the top wins, f of x is just going to keep on going, whether up or whether down doesn't really matter. If the top wins, think of it this way. If we had like a cubic on top and a linear on bottom, that was kind of hard. I'm asking you guys to visualize. If we have a cubic on top and a linear on bottom, if we did synthetic or long division, what would the answer be? What kind of function? A cubic on top, a linear on bottom. If we divided with synthetic or long division, we'd have a quadratic. Oh wait, quadratics just go on forever, right? They're not having any horizontal asymptotes. So if the top wins, we still have a polynomial. It's going to go forever, some direction, even, odd, just depends. But it's not getting closer and closer towards any horizontal line as it goes to the ends of its behavior. So if the top wins, no horizontal asymptote. Some sort of polynomial is going to go on forever. Forever up, forever down. It's approaching one of the infinities. Leading coefficient test and behavior, check that. But number 2 says who wins? Bottom wins. If the bottom wins, that division is not going to get you a polynomial. Top wins in the first one, bottom wins in the second one. The third one, their degrees tie. If the bottom wins, the top isn't strong enough to go to infinity. The bottom is going to keep cutting into it as you go to the right or to the left as x approaches infinity or negative infinity. Long story short, you are going to have a horizontal asymptote. And it's going to be the most drastic one because it's going to be just 0. If the bottom wins, eventually as you plug in x's to infinity or negative infinity, the whole value is going to go to 0. And last but not least, if there's a tie, degrees of the top and bottom tie, you are going to have a horizontal asymptote, but the horizontal asymptote is going to be at y equals, and here's the struggle, the ratio of the leading coefficients. If you guys want to be ready for really snazzy problems on an AP test in calculus, which you probably won't see problems quite this hard, there technically is an extra little note right here. You have to check the positive and negative. There technically is a note. There are harder problems where you technically have to not just take the ratio, but check the sign, and that doesn't mean looking at the function. That means actually plugging in like we did with the vertical asymptotes. There can be harder problems where you have to check the sign. I'll try to show you guys one, maybe not today, maybe tomorrow, of a tricky one that the calculus kids have seen. And the math and some of it, you might not understand what they're saying, but basically it's a horizontal asymptote problem. So, my question to you is, sorry, you missed on this. My question is, who wins? What are you looking at? Degrees, and degrees is the highest power of x of each, the numerator, the denominator, right? Who wins, top or bottom? Because I had a squared up top. Top wins. Look at your test. What's my horizontal asymptote? None. Now, pause. Do I have a vertical asymptote? People get these confused all the time. Do I have a vertical asymptote?
Yeah.
Yes, because I do have a domain that's restricted, right? X can't be 0. Can I cancel out the x with any factors at top? There's no x there. I can't cancel. So since I have a domain restriction I can't cancel, I do have a vertical asymptote. X cannot equal 0. But the horizontal asymptote says top wins, I have none. Does that make sense, guys?